Hi there and welcome to the video. In this video we are going to talk through applying the cosine rule. The cosine rule can be used on a non-right angled triangle when you want to find a side and you know two other sides and the angle in between them, or if you want to find an angle when you already know all three sides. So the criteria for applying the cosine rule is different to applying the sine rule, and we'll look into that as we go through the explanation. First thing to talk about is the way that we label the non-right angled triangle. We label it in exactly the same way that you label for the sine rule, and that you label to apply half AB sine C in order to find area. And the way we label is we put capital A, B and C on each of the angles, and then the lowercase letter is opposite the angle of its capital. So A is opposite capital A, C is opposite capital C, and B is opposite capital B. From there, we're able to apply the cosine rule. There's two different forms of the cosine rule, and they look like this. The first form is when we are trying to find a length. So we're going to apply this formula when we're trying to find a missing length. The second version of the formula is actually this formula rearranged. And again, we'll look at that in an example later in the video. And this form of the equation is used when you're trying to find an angle, when you want to find an angle. One thing to notice here is in both equations, what we are trying to find is lowercase a or capital A. So when we are thinking about labeling our triangle, we are always interested in where our A's are going to be. And often we'll need to relabel the question in order to be working with our A's. Otherwise, we need to learn 6 different forms of the equation, 6 different ways of writing out the equation. So just for simplicity, sometimes it is easier to relabel the question and focus your A's on the side or angle that you're trying to calculate. Again, that should make sense as we go through a few examples. Okay, so here is my first example of applying the cosine rule. We've got a non-right angled triangle. We know two sides and the angle in between, and we're asked to calculate the length AC. So I want this length here. I can't apply the sine rule because I don't have two matching pairs. I don't have an angle and the opposite side, and then another angle and its opposite side. So the criteria for sine rule and cosine are different. The way this question is set up is leading me to use the cosine rule. Because I'm working out a length, I'm going to use this form of the cosine rule. A squared equals b squared plus c squared minus 2bc multiplied by the cos of A. So the first thing I've done is I've labeled my diagram. You'll notice that this was capital B, and when I've wrote out my labeling, I've changed it to capital A. So that now means that what I'm trying to work out, the length A to C, is going to be labeled little a, which corresponds to the order of the cosine rule that we're going to use. If I just went ahead and labeled this side would be little b, which would mean we would need to rearrange the formula. So for a bit of consistency, I relabeled the diagram so that little a was on the side that I want to work out. So now I'm going to go ahead and substitute the values I know into the cosine rule. I know little b is 10 I know little c is 7, and I know capital A is 35. So I've taken the cosine rule and I've substituted in the values I know. You can see I've highlighted them in yellow there to show the bits that I've substituted in. This was all put into my calculator and it came up with the value 34.31871. I haven't rounded my answer just yet because I'm not finished. That is the answer to a squared, but I don't want a squared, I just want a. Therefore, I'm going to square root that value to find my value of a, which I've rounded to 3 significant figures. So the length of AC, which I've labelled little a in my new drawing, is 5.86 centimetres to 3 significant figures. Look at the way I've presented and look at the way I've shown all my working out, including the substitution, to get my accurate answer. Let's have a look at a further example. Okay, question 2. So this time I'm dealing with a non-right angle triangle where I know all 3 sides and I'm asked to work out an angle. So again, that is suggesting that I need to be using the cosine rule. It meets the criteria for applying the cosine rule. Because I'm working out an angle, I'm going to be using the second version of the cosine rule, which I showed you earlier in the video. First thing I've done is I've labelled my diagram. Again, because I want to find the value of P, this is the angle I want, I've ensured that I've labelled that as capital A when I have drawn out my diagram. That just means that we can apply consistently the same cosine rule. Then I've went ahead and finished my labeling. Little a is opposite capital A, little b is opposite capital B, little c is opposite capital C. This is the version of the cosine rule I'm going to use. Remember, it is just a rearrangement of the cosine rule we used in the previous question. It does start with cos A, which is why I've labelled the angle P, which is what I'm trying to find, as capital A. So now I know that little c is 2.8, little b is 3.6, and little a is 5.3. I'm going to substitute those values into this version of the cosine rule. Again, I've highlighted in yellow, so you can see where those substitutions have taken place. That all gets put into my calculator, and this is the value I end up with. But at this stage, this is the value of cos of A, and we only want A. So therefore, I'm going to work out the inverse cosine of this value. So because it was cos of A, I've used the inverse cosine of that value to tell me the value of capital A. That'll go into my calculator. Calculator will tell me that rounded to 3 significant figures, the angle P, which I've also labelled as capital A, is 111 degrees to 3 significant figures, or 111.2 when I round to 1 decimal place. Again, look at the way I've approached the question. I've identified that I need to use the cosine rule. I've labelled or relabelled correctly to ensure that the A's are where I need them to be. I've decided what version of the cosine rule. I've completed some accurate substitutions. The calculator has helped me solve the question to find my correct value of P. Okay, so here is a third question. If at this point you want to have a go at this question yourself, then please just pause the video now and answer the question. Or if you want to listen to one further example, I'm going to talk through the question now. Okay, the question is asking us to calculate PQ. So we want to know the length of this side. When I come to label this, I'm going to ensure that this side here is small a, which means I'm probably going to call this capital A, and then the P and Q would also be replaced with B and C. So I've drawn out the diagram again, and as just discussed, little a and capital A. So what I'm trying to find, what the question is asking me to find, is now labelled as little a. Because I'm being asked to work out a length, this is the version of the cosine rule I'm going to go ahead and use. I know that little b is 7.6, and I know that little c is 8.4, and I know that capital A, the angle, is 62 degrees. I'm going to take those values and substitute them in to the cosine rule. You can see where those substitutions have taken place. All this is going to be put into my calculator, which is going to give me this value, 68.3778, and so on. At that stage, that is the value of a squared, and we just want to know a, because that would give us this length. So we're going to square root that value, which is going to tell me that the value of a to three significant figures, this distance here, is 8.27 centimeters. Very well done if you worked ahead of me there and you were able to produce this diagram labeled correctly and apply the cosine rule to get this value. 8.27 is the distance between P and Q. Okay, so what we know so far is we use the cosine rule when the triangle is not right angled and there is not a matching pair. So if you have two matching pairs in terms of sides and angles, that would suggest you're using the sine rule. Other than that, we will need to think of the criteria and apply the cosine rule. We know we label the non-right angled triangle like this, with the capital letters being opposite their lowercase letters. Capitals are always placed on the angles, lowercase on the sides. This is the version of the cosine rule that we use for sides. There is also a version that we've looked at, which is a rearrangement of this one, which we use for angles. We could use this version for angle questions as well, which I'm going to show you in a few slides time, and then you can choose your preferred equation when you come up with then you can choose your preferred equation when you come up against some exam questions. Okay, if you would like to have a go at this question, just pause the video now, otherwise continue listening to my explanation. We can see it's not a right angle triangle. We can see that there is not matching pairs which would allow us to use the sine rule. So therefore we've decided to use the cosine rule. We're going to label the sides and angles using our capital letters and lowercase letters. I've labeled this A because it is the angle I know, but also it's going to correspond to little a being placed on our missing side, which is what we want. So I've labeled the triangle correctly, ensuring that the A is on the value I'm trying to find. There's my cosine rule. I'm going to substitute in my values that I know from the diagram. There we go. This bit here is going to be put into the calculator. Ended up at 22.026 and so on. That would have been a squared, of course, so we're going to square root. Gives me a value of a rounded to two decimal places of 4.69. So little a is 4.69, which is telling me that the value of x is 4.69. Very well done if you worked ahead of me for that question. Okay, here's another question to try. Again, if you want to pause the video and work ahead, that is great. Otherwise, keep listening to my explanation. So this time it is a worded question. The diagram we have to draw out from the information in the question. We're going to draw the sketch. A man starts at village of Chartham and he walks 5 kilometers due south to Aylsham. So I've started at C and I've went 5 kilometers due south to A. He then walks another 8 kilometers on a bearing of 130 degrees. So this is now my north line in a bearing question. I'm going to calculate or measure the angle of 130 degrees. And then the distance walked from A to B to Bartham will be 8 kilometers. There we go. What is the direct distance between Chartham and Bartham in a straight line? So what we're trying to find is the value from C to B. There we go there. So I've took this information and I've drawn out an image. When I've come to measure these lengths, obviously I've used centimeters because 5 kilometers wouldn't be an appropriate unit of measure, which means whatever answer I receive here in centimeters, I will then convert to kilometers to answer the context of the question. So the way things are labeled up, what I'm trying to find is the length CB, which is going to be little a. So I don't need to relabel, it's already labeled correctly. Is it a right angle triangle? No, it is not. We don't have the matching pairs that would suggest using the sine rule. So we're going to use the cosine rule. We're going to finish off labeling up. And you can see that little a, the value we're trying to find, already lands where we want it to land. Little b and little c as so. Then we're going to substitute our values into the cosine rule. Then our calculator is going to start helping us, giving us the value of a squared being 140.42, which we're going to square root, giving us 11.85 for the distance from C to B. Centimeters on my diagram, but in the context of the question, kilometers. Okay, so this time we are asked to find the missing angle theta. If you want to go ahead and answer this question, then pause the video now. Otherwise, continue listening to my explanation. When I approach this question, I'm going to use the first version of the cosine rule, just to show you that you can also apply the first version and rearrange it during the calculation. You can, of course, use the second version as we've seen earlier in the video. It is not a right angle triangle. We don't have those matching pairs. What we do have is 3 known sides, and we're wanting to find an angle, which is one of the criteria for having to use the cosine rule. The angle theta, which is what we're trying to find, has to be labeled A. And then we can label the other angles. Then we can go ahead and label our little a, little b, and little c. As I mentioned, I'm going to use the first version of the equation because during the calculation, things will get rearranged anyway, and we'll end up with the correct answer. If I substitute in little a, little b, and little c, it would look like that. Just tidying things up a little bit. And then you can see at this point, things have been rearranged. So we've ended up rearranging things to have cosine of theta on the left-hand side. Cosine of theta, which is cosine of capital A, which is what the second version of the cosine rule looks like. So essentially, it is a rearrangement of the first version, and we can apply either. Calculator will help us with this, and then we'll need to take the inverse cosine of that value. So on your calculator, that will be shift and cos. That's going to tell us that the value of theta, the size of this angle, is 62.72 degrees. Okay, so here is a task for you to have a go. On the screen, I've placed 6 questions. Some of the questions ask you to work out a length. Some of the questions ask you to work out an angle. So we will be testing or practicing with both versions of the cosine rule. You can see that the way the questions are labeled differs from question to question. Some questions aren't labeled at all, and some have used letters that aren't A, B, and C. So for each question, you're going to need to draw out the question, decide if the question needs to be relabeled, so your A's are where they are needed, and then apply the cosine rule to find the length or the angle. Okay, at this point here, I'd like you to pause the video. I'd like you to work through all 6 questions, applying the correct cosine rule, showing me full working out, and finding your 6 solutions. Could you pause the video now, please? Okay, welcome back to the video. I'll just go ahead and put up my solutions to these 6 questions. So for each answer, I've rounded to 2 decimal places. If you could just take your time to mark up these answers, and very well done if you were able to calculate all 6 correctly. Okay, this is your next task. So on the screen, I've placed 6 IGCSE extended questions. For each one, it's asking you to either find a length or an angle. Just like on the previous task, you may have to relabel, and you need to apply the cosine rule correctly. Again, I'd like you to pause the video at this point, work through all 6 questions with full working out, correct notation, like I showed you earlier in the video, and hopefully finding 6 correct answers. Could you pause the video at this point, please? Okay, welcome back. I'll just go ahead and put up the 6 solutions. And there are my 6 solutions. Well done if you were able to use the cosine rule to achieve all the 6 answers in those questions. That will show a very good understanding of some quite challenging IGCSE exam questions.